For this lesson, the assets provided in the video description are needed. Download the zip file and copy the sprites and sounds folder to the Godot project folder. As soon as you return to Godot, it will import all the possible files to use in the project. In Godot, anything that can be presented in the game is a scene. A scene can contain only one node or be a tree of different nodes with different functionalities, and as you might imagine, the game itself is a set of scenes within each other. Let's try building an element of our game to better visualize this concept. Since our game will be 2D, switch the view to the two-dimensional environment by clicking on 2D. Here we are seeing an empty scene. This scene has no node and does not even exist as a file because it has not been saved yet. Every scene must have a main node or root node where all the other nodes will be attached. The main node or parent can be directly the type of the functionality we are implementing, for example, an image, which depends on the Sprite2D node. But however, the following nodes will depend on the functionalities of the main node, and for that reason, it is preferable to always have a more basic node as a root, and then use the functionalities suitable for our objectives, rather than having a limited node that prevent us from performing some operations later on. So, in this case, we will not use the Sprite2D as a root, but rather a node 2D. Here we can add a Sprite2D and then configure the image or sprite we intend to use. Another easier way to add nodes is simply to drag the files to the scene. In this case, Godot not only adds the correct node, but also changes the node name to match the file's name. This sprite contains almost all the assets we will use in our game. This is a common practice because, in a very simplified way, whenever the computer has to draw an element on the screen, the information comes from a file, and if all the sprites are contained in a single file, the computer reads this image once, and then distributes copies and parts across the screen. This way we reduce the so-called draw calls and increase game performance, especially when we have dozens or thousands of elements flying across the screen, which is what will happen in this game. Generally, we will have the player pointing up and moving in all directions. Also, the enemies who point down and only move down. The player has 4 cannons that fire lasers upwards. The enemies have 2 cannons that also fire lasers, but downwards. If all elements are scenes, then what is the most efficient way to build this scene? If we are going to use something more than once, that something can be a scene that we instantiate when we need it. It's like a Lego castle. The castle is unique and complex, but is built by many identical parts. What we have to do first are the individual parts, so we can use them later to build a more complex scene. Let's analyze the player. The player's ship consists of 3 main elements: the body, the cannons, and the lasers. If the ship has 4 cannons, we can build 1 cannon and copy it as many times as we need to complete the ship. On the other hand, the cannon fires lasers infinitely. This means that we will need to build a laser that will then be used by the cannon. By copying the cannon, we are also copying the lasers that are part of the cannon. Looking at the tree structure of the player scene, we have the ship, and inside it, the 4 copies of the cannon. The cannon will have a script that will place a laser whenever the space key is pressed. The laser will not be directly a child of the cannon because it must be independent of its movement, but the cannon must be attached to the ship to follow its position. This means that if the ship moves, the cannon goes with it, but the lasers continue to fly where they are. For the aliens, the process will be similar, with the difference on the movement being from top to down. All this action takes place on a game level, and to house all of these elements together, we will also have to build the level 1 scene. Let's then start creating several scenes and start integrating them into each other. In the main file folder, we will create a folder called Elements, where we will keep all the scenes that are elements of the levels. This scene that has no name yet can be saved as player within the Elements folder. The player should only have one of the ships, so by selecting the sprites to the node, we can change its settings in the inspector. In this case, we will activate the region option, and in the edit region, we delimit the player's ship. Be careful with the clipping, as everything inside the rectangle will appear and everything outside will not. In the end, we click Close and we already have the player ships isolated. We can now create a new scene by clicking on the plus sign on the top of the panel, and once again we select a node 2D as root. We can already save this scene as level 1 outside of the Elements folder. In the file system, we can see that we have two scenes in different places, but both can be used multiple times within each other. In our case, we will use the players inside the level 1. To do this, make sure you are editing level 1 and drag the player scene into it. To make sure the tree does not get too confusing, we should change the name of the main node of each scene to something representative, because when you add an element to another scene, the name that will appear is the one of the root node. As we can also see, if we need more identical elements to this one, just drag them to the scene. In this case, Godot changes the name, incrementing it with a number. If we press play or the F5 key, Godot will run the scene configured in the project settings, application, run, main scene. The purple rectangle is what will appear in the final render. It's like a default camera, but to have control over the camera, we have to add a camera 2D. This appears in magenta and can be configured in the inspector. At this moment, the only change we will make is to change the zoom to 0.1. The camera area gets bigger and the game elements get a more suitable size. In my opinion, it is preferable to have all sprites at scale to each other and all elements at 100% of size. This will facilitate interactions later on. Now, by pressing F5 or play, we then see our ship lost in the universe, but without moving. In the next lesson, I will detail the characteristics of the script and the C# language, but now we will copy a small script just to understand the addition of functions to nodes. Each node can contain a script. In this script, we can program whatever we want, and in this example, we will program the movement of the ship. Start by creating a scripts folder. And within it, a C# script inheriting from node 2D with the name player. Grab the script in file system and drag it to the root node of the player. An icon appears to signal the presence of a script in the node, and in the inspector you can see it in the last configuration parameter. By clicking on it, Visual Studio opens to allow you to edit the script. In summary, the script has three major blocks. the class, the ready, and the process. The class is the script itself. Everything that this script has to do must be within the brackets of the class. The ready function, called method in C#, serves to configure the script at the start. What is inside these brackets happens only once when the node appears in the world. The process method happens in all game frames and serves for the game logic to happen. With this in mind, what we want to happen every frame with the player's ship is the movement in response to the WASD keys. To do that, before the ready method, we declare an int variable named speed and valued 600. At the end, we use the semicolon to end the statement. Inside the process method, so every frame, we have to do three things. Prepare the direction vector, change that vector according to the keys pressed, and increment the position with the vector. So we declare a variable of type vector2 called movement with a value of new vector2. Next, we check if each of the keys is being pressed. If, open parenthesis, input dot is key pressed, open parenthesis, key dot w, close parenthesis, is equal to true, close parenthesis, enter, open brackets. So if input is true, whatever is within these brackets will happen. In this case, movement.y equals itself movement.y minus speed times float delta. In Godot, Cartesian coordinates have the horizontal axis x with positive to the right and negative to the left, and on the vertical axis, the y, positive down and negative up. Therefore, to go up, we must subtract y. The delta issue, we will talk about it in another lesson. In the end, to increment the position, we simply add the movement to the position. Position equals position plus movement. If we save and return to Godot, when running the game, we can now move up by pressing W. Doing the other axis is copying the code and changing the keys, axis, and mathematical operations. So down is S, and speed is added to the y-axis. To the left is A, and it is subtracted on the x-axis. And to the right is D, and it is added on the x-axis. We save and test again. As you can see, the ship already moves in all directions, and because we are multiplying the movement by the speed variable, we can easily change the speed by just changing the speed value. The exercise for this lesson is to copy the entire project as demonstrated and create 3 aliens in separate scenes, ready to be placed in level 1. The challenge is to create a script to use in the aliens that makes them move automatically downwards.